Thank you guys all for coming. I feel really honored to be here and to give this talk. Hope you guys are having a good time. Guess this is like basically the next to last talk of the conference. So thanks for coming to my room. All right. So my talk is titled "Zig Loves Elixir," and so let's get to it. So I'll give you a little bit of background about me. This is what I look like on the internet. I've been programming since the 80s. I am a former biochemist, so I spent about a decade doing that sort of stuff. You can find me on Twitter at dnautics. That's probably the easiest way to find me. And occasionally I make these really strange Elixir deep dive videos going into deeply about how things like testing works in Ecto when you have async true, which I think is really awesome, by the way. So if you don't know how that works, you should look into it and maybe check out some of my videos. So how did I get to Elixir? So like I said, I've been coding since the mid 80s, but nothing real, just educational learning how to code stuff. My first real programs were in C and C++ in the early 2000s. And then as the web started taking off, I learned some Ruby, which I stuck with for quite a while, but none of this was professional. Probably the closest thing to professional that I did in Ruby was when I was a biochemist, there was a Chinese research institute that had published the genome of something, and they claimed it was open source. They made it really hard to get the data off of their website, and so I wrote a Ruby script that scraped it, and then they took it down the next day. So I think they were just doing it in name only. Open source and name only. I started to learn Julia, and then I got a real programming language job off of Julia, doing some theoretical computer science and numerical computational performance experiments. And then I got a job where doing more web dev-y stuff was necessary, and I loved the functional programming aspect of Julia, and I loved the sort of good stuff about Ruby, and I found Elixir, and I've kind of stuck with it up till now. I currently work for a company called Vic.ai, which takes invoices and does machine learning processing on it and makes the lives of accountants a lot easier. We are hiring, so if you're interested in working in that field, we are definitely looking for Elixir developers right now and for the near-term future. So. But I've also found more recently a new programming language called Zig. Probably somewhere around 2019 is where I found it. And so, why do I choose the programming languages that I choose? And this is kind of, actually I've got a pretty good track record. At the risk of labeling myself as a hipster, I was into Julia before it was cool. And not super early on Elixir, but pretty early, and Zig is for sure an early stage programming language. It's really started taking off in the last few months. Well, I think it boils down to this question: does your programming language spark joy? And this is what was a big thing with Ruby in the early days. With Mats, can we make a joyful programming experience? And what do I mean by that, and why is it important? Well, look, one of the things that I do is connecting to third-party SASs, and that's many times just really thankless and completely mind-blowingly tedious job. One time I connected to a GraphQL system, and for some reason my generalized GraphQL queries weren't working, and then it turned out that they'd misspelled their query route as transacton instead of transaction. You got to put up with this sort of stuff. And at least if your programming language has very few footguns, it's very clear what's going on. It's easy to write clear code. Declarative is helpful, but not necessarily something you absolutely need. But they're just things that in a soft sense makes it so that your experience as a developer is not that stressful. And it can be in a lot of languages with a ton of boilerplate in all the wrong places. And I find that Elixir and Julia and Ruby and, as you'll see, Zig fit all of those characteristics that, just to be crude, make it less of a pain in the ass to program in that programming language. and get the stuff that you want to do done. And so here are some commonalities between Zig and Elixir. The design of both languages is heavily pragmatic. So Elixir is actually, in my opinion, built on 2 levels of pragmatism. So Erlang itself is not like when Joe Armstrong and Robert Verding and company built Erlang, they didn't build it to fulfill some sort of like theoretical idea of what a programming language should be. They started from what do people need and how do we get them there with as little friction as possible. And Elixir is kind of a modern take on that. There's a lot of stuff in Elixir that's just there. I mean, io.inspect, right? And come on, let's we all know that we're println debugging, not using the debugger. Like, just make it easy and make it useful, right? And Zig kind of feels that way in many ways for me. The design of both languages is modern. There are no lexical macros in either language. So if you remember C and Erlang, actually, they both have this thing where you can just inject lines of code as text into your program. And that doesn't exist in either of these 2 languages. First-class documentation, first-class tests. Both languages have a compile time aspect that is a way to run the language that is the same as the runtime way to run the language. And both have like a build system that is in the language itself. So if you know C, there's like make, right? And that's like a whole other language you got to learn. And actually, in fact, for Erlang, you got to use make, right? Many times. Things have gotten a little bit better over time, but a lot of Erlang projects are compiled or built. The build is orchestrated using make. And so, by contrast, in Elixir, we have mix.exs, which is itself an Elixir file, an Elixir script. And so it's easy to comprehend what's going on because you don't have to learn another language to figure out what's going on. And similarly, Zig has this build.zig. And I forgot to mention, the reason why I keep referencing C is because Zig is a low-level programming language. It aims to be a competitor to C, and possibly even a replacement for C. And so, I'm not like trying to proselytize people over to Zig away from Elixir here. I think that the 2 languages can really mesh together. So now that I've described a little bit in qualitative terms what Zig looks like, I'm going to give you a quick tour of what Zig looks like by comparison to C and C++ on the left. So these are 2 programs that more or less do the same thing. I stole this from https://hackaday.com, and if you go to this site, they talk about actually the major foot gun that's in the C code. So if you have already seen this, it's a challenge to figure out what the foot gun is in the C that the Zig doesn't have. But yeah, so if you're familiar with what Zig is, you do that as an exercise. For everybody else, I'll go through a few points here. So on the left, C has these weird include statements that bring things into your namespace. And also, those are macros, right? Because they have the hashtag sign or pound sign or octothrop, whatever you want to call it. By contrast, Zig has these @import, which are built-in functions. And what's going on there is it's bringing the standard library in as a struct. So that name standard std is bound to basically a struct object that you can access in the rest of your code, and you can see it getting dereferenced elsewhere in the code. Okay, so C has this is super well known for having this, and C and C++ are super well known for having this weird spiral typing. So how do you read the type of that buffer? You start with buffer, and then you go to the right, and then, okay, it's an array of something, and then you go to the left, and you see it's an array of cars, okay? And then also that means that that car character, the car identifier on the left is context sensitive. That could be anything. It could be any variable type that you've created elsewhere. So it makes it really hard to parse and understand what's going on for both humans and for computers. By contrast, Zig on the right is kind of more along the lines of modern languages like Rust, where you've got the name of the identifier, and then you can see immediately to the right, oh, it's an array. In the case of Zig, the size of the array is a compile time known value, and then it's an array of U8, which is car. Another nicety that Zig has that I'll show you in use like further down is this defer statement. If you're familiar with Go, that should be a thing that you're familiar with. But basically, what it says is at the end of when you leave the scope of this block, do this thing. And what that means is for Zig, you don't have to have like weird control flow when you need to clear out a resource that you have asked for. So in this case, we're asking for the for a file handle, and at the end you close it. And this protects you from the case where if you have some sort of like weird early returns. Now, you might not see any early returns because there's no explicit return statements here, but there are 3 of them. And what this try is it's a shorthand for saying if what is to the right of try errors, just quit early and return that error. And you can see the function signature of main here has a bang in front of it, which means that I can return an error. So this is a very convenient way of like quitting early, and you know that even though it quits early, it will do that file.close. OK, so this will all come in important in one of the demos. OK, so I said that Zig is a low-level language, and how is this going to relate to ElixirConf? Well, let's use Zig to write NIFs. And there are 3 like key points that I want to like cover in here. The first is that it should be possible to write NIFs with the same level of joy as writing Elixir code. The NIFs should have good integration with Elixir, and the NIFs should be a good citizen of the beam. All right, so what is a NIF, and why would you use one? It's a way to access the low-level C ABI from the beam. And you might use it because if you need operating system features that are not provided by Beam. So in my previous job, I was writing orchestration code for virtual machines in a custom cloud, basically, and renting those out to customers. And I wanted a way to check in on the virtual machines and the hosts that were running the virtual machines. And so I needed ICMP ping. And at the time, it was not possible to run ICMP ping from the beam. And so I wanted to hook into Zig's socket library, or socket part of the standard library, and use that to access a raw socket and get ICMP ping. OK, because before that point, I was shelling out using os.cmd to fping, and that's really bad, and you can cause zombie processes. It's no fun. We had downtime because of that at one point as well. However, so I actually did finish that, but then like 2 weeks after OTP22 came out with ICMP ping support in their new socket module. So this whole thing is just really a big yak shaving operation to get ICMP ping into the beam. But you guys get to see this talk as a result, and there's some cool tech that got built as a result. OK, another reason is you might want to use a library written in C++ or shared library with the C ABI. I will show that in one of the demos. And if you just want to go fast, the beam is not exactly known to be a computational speed demon. So one way to deal with that is to run a NIF. But all of this comes with this like huge caveat that NIFs break the safety guarantees that the Beam virtual machine gives you, and also, to some degree, the failure domain isolation. So if you start running a NIF and it does something bad, common ones are seg faults, panics, you're going to bring the whole system down with you. And that means everything in all the other processes that are running on your virtual machine at that time. So that's why people often look towards Rust to do it. But I'm going to show you a sort of one of the safety problems that can happen even if you are if you're not careful about how you write your NIFs in general, and it has nothing to do with like memory safety. Okay, so are you using NIFs? Well, there are actually built-in NIFs in the Beam. I think it was maybe about 2 or 3 OTP versions ago, they started moving a lot of what were known as BIFs, built-in functions, to NIFs. So whether you realize it or not, you're probably using some NIFs in the Beam. They're written and maintained by the Erlang team at Ericsson. There are also some pretty common libraries that use NIFs. So Come On In uses a NIF for its bcrypt stuff. AppSignal famously used a NIF in Rust to get OS profiling stuff, like how much memory is your VM using. And Porcelain is I think it's a pretty common library to run processes in a way that protects you from zombie processes, and it uses a Go NIF. Okay, so one of my goals is a good integration between Elixir and Zig. And the design choice that I made here was to make NIFs inline code. So I'm going to show you an example of that. And so this is my first demo. Can everybody see this? I hope it's not too small. Basically, here's how it works. To use Zigler, you want to just have this use Zig macro, and it can take a bunch of options. In this case, we're going to use this libblos library. By the way, does anybody know what language libblos is written in? That's right, it's written in Fortran. I mean, there's a C version as well, but this one is written in Fortran. And so we're calling Fortran code from Elixir with Zig as an intermediary. The libblos Fortran code does, however, expose a CABI, which you can think of as sort of like the common denominator for how binary executable codes can talk between each other across most operating systems. And then we're going to include a .h file. So what this will show you is a little bit of C integration alongside just running pure Zig. OK, so you take your Zig code and you put it in the sigil Z block. And for any function that you want to export into your module, you label it with these // which is a doc comment in Zig, NIF : and the identity of the NIF. So in this case, I'm doing this AXPY function. If you are familiar with BLAS, that is an AX plus Y linear algebra operation. And you just write your function as if it were a Zig function. In this case, it's going to take a float64 and two slices of float64, and it's going to return a beam term. And we're going to call the cblast DAX plus DAXPY function that Zig just knows exists by reading and parsing the cblast.h file. And here we see that taking that import and assigning it to a struct, and we call it as if it were a struct, and then we just do this stuff. And we're going to get to this in a bit. And then we're going to make an F64 list, which will then output the solution vector. OK, so I do want to show you one quick thing. So suppose I wrote something crazy like so that foo identifier doesn't exist anywhere. And so what we should see is this underline. And what happened is that it identified that there is a Zig compiler error going on there. And it tells you what it is, and it highlights the correct line. OK, so let's go ahead and do this. OK. Oops. And then let's say 3, and then we're going to do 1, because we'll do the array 1, or the vector 1, 2 with the vector 2, 3. And so 3 times 1 is 3, plus 2 is 5. 3 times 2 is 6, plus 3 is 9. So got the right answer. So we just called BLAS. All right. So here are some of the specific features that I chose to integrate between Elixir and Zig. So one thing is type specs are inferred from the Zig function headers. I'm going to show you that in a second. Help documentation is generated from Zig doc strings. The line numbers for compiler errors are translated. That's how we got that red underline. Error return codes are merged into Zig stack traces, which I'm going to show you in a second. And in the second demo, I'm going to show you that Zig unit tests can be run from exunit. OK, so let's look at the type of this. So demo1.axpy. So first of all, you can see that the help is the doc string from Zig. And you can see that this is correctly typed. So float, array of list of float, and it outputs nil. And if I were to, for example, put something that doesn't make sense, it's going to give function clause error, which is exactly what you would expect. OK, so I did show you that we have this. First of all, this function can return an error. It's got that bang in front of the result type. And I have this weird if a equals 13.0, return error.unlucky number. So let's go ahead and try and trigger that. Let's put this back. And then we'll make the first one 13. And you see that it forwards that error as a Elixir exception. And it even gives you a trace of where that error came from, line 21, which is right here. OK. Thank you. So obviously, there's a lot of glue code that has to happen. I'm going to show you a little peek under the hood of how this works. So this is the file that gets assembled by Zigler that gets turned into the NIF. And so you can see right here is the directly copied content from what was inside that sigil Z. And you can have multiple sigil Zs in your code if you want. And this is how it can remap what file and what line number it came from. It injects these comments there. It builds these shim functions, which are the functions that are actually exported using the CABI. And you can see that there's a bunch of utility functions here. Raise function clause error. So that's where these functions, it does the type checking on ingress and makes sure that you're doing the right thing. And yep, so that's kind of what I want to show here. And then here's some kind of general boilerplate that you have to do for NIFs in general. And this is this part, I think, is some stuff that you can, well, both this auto-generated stuff and this sort of lookup table at the end are things that you can really mess up if you're not careful in C. And so the more modern NIF libraries like Rustler and Zigler, of course, take care of this for you and auto-generate it. You don't have to think about it. OK. Let's do unit tests. So I got to get out of here. OK, so here we have a quick Zig code block. It's labeled, the NIF here is labeled 42. And you can see that all it does is outputs the number 42. And we're going to, this is exactly what you would expect for a standard Zig test. As I said, tests are first-class citizens in Zig. But you can't necessarily run Zig tests to execute these tests, because you might need the backing of the Beam virtual machine to run some of the functions that you're writing, right? We might do some more integration E tests that need a lot of machinery that doesn't exist if you just run the Zig as it is. So what I have is a module called zig.unit and a directive zig test, which looks a lot like doctest and was inspired by doctest. And you just drop this in the exunit.case. And so what happens if we run mixed test? It'll recompile the NIF and run your tests. There we go. So the test, what is life, failed with error, test unexpected result. And it tells you what line it was. And there's maybe a few places where I should probably fix some of these line numbers, but upcoming versions. Now, what happens if, and so it says one zig test, one failure. So this is what you would expect out of something that looks like a doc test, right? So if we change the error on that, we should expect for it to say one zig test, no failures, or one zig test in green. There we go. Right there. Okay. The second goal that the third goal that I talked about was that NIFs should be good citizens of the beam, and there are two ways in which I'm going to talk about this in the context of this talk. The first is that allocating memory should be visible to the virtual machine. So Erlang virtual machine keeps track of how much memory it's using. If you use C standard library malloc or JE malloc, which most NIF programming languages or NIF systems use, it's going to be completely invisible to the Beam virtual machine. It can't track it. By contrast, Erlang does provide you with a special function that will allocate memory and is tracked by the virtual machine. Now, the fantastic thing about Zig is that it is completely agnostic about allocators. There are a handful of allocators that are supplied by the standard library, but most of the standard library functions do not call them directly and ask for you to provide an allocator. So if you want to make, if you want to make a hash map, or if you want to make some sort of linked list, you are typically passing an allocator in, which means that you can optimize your allocator for whatever purpose you want. If you just want to do a shoot and throw away later, you can do an arena allocator. If you want a more sophisticated memory managed system, you can use the standard library general purpose allocator. You can even shim malloc and use malloc. And there's one case where I just was like, I need to shim cmalloc because it does this really super fast zeroing out of your memory space. So you do that, and then boom, you've got like memory that's zeroed out real fast. So because Zig is agnostic, it makes a good pairing with the Beam virtual machine because you can hook in the Beam allocators to the existing system, and it should just work across the standard library. I also want to support all forms of NIF concurrency. There are five forms of NIF concurrency. One is not concurrent at all. One is dirty CPU, dirty IO, which I think Rustler pushes you towards. There's threaded, which will spawn an operating system thread and then run your NIF inside the operating system thread. And then there's yielding, which I'll describe in a bit. So let's take a look at that demo. So basically, the components of this is just a simple function, loop yielding. We're going to do something crazy and allocate like 10 megabytes of memory, and then we're going to free it. Then we're going to loop forever, and that's it. This is what the function does. Now, you'll notice that I have this try beam.yield, and that's super important. And I will describe how that works in a bit, but let's just do the demo first. OK, so spawn. So we're going to spawn this NIF in its own process. And I forgot to check that what the memory was, but that is erlang.memory. And then so we can see that we've used 39 megs of memory, or 39 megs of memory. OK, so now we have that process that we created. It was 204, right? So process.kill. Or actually, exit. And then let's look at how much memory we have. And you can see that it has gone down by 10 megs. So it went from 39 to 29. OK, so what happened here? So clearly, we wound up freeing that memory at some point. So let's describe how this works. So this is the yielding NIF life cycle. So you spawn your Beam process executes the NIF. Zigler has this function that's a NIF harness. And the harness takes out something called a resource. And what a resource is a garbage tracked item inside of the Erlang virtual machine. Then it allocates the memory in the heap and creates something called a frame, which is a context for the function to run like in general. It then starts running the function asynchronously inside of that frame. And then you saw in the while loop we had a bunch of the yield statement. So the yield statement does is it takes this async function, temporarily suspends the function, and drops back to the event loop. After so many amounts of these yields, it says, I'm consuming about 1 millisecond of time, and that's how much the beam is like willing to let me use. And then after that many yields have happened, it yanks control away. It doesn't restart the NIF, and then it goes into the C tail call. Now, this is super annoying to code in C, and this is why most people don't use yielding NIFs when they write NIFs for the beam, because you've got to like do this annoying C tail call where you pickle the state of your function, and then you stash it somewhere, and then you got to unpickle it at the end, and too much stuff to do. But because Zig has this like super awesome async function call system, we don't have to do that. We can just like pickle the reference to this async run frame, right? So then, maybe the beam virtual machine is doing something else and giving some time to some other process, and it comes back, and then the event loop gets some time back because it re-enters from the tail call and unpickles everything for you, at which time it jumps back into this async function, yield, jump back and forth, and another millisecond happens, and then it gives its time back. So this is like just a very cooperative system where the NIF is running cooperatively with the beam virtual machine. At some point, I called process.exit, and that terminated the beam process internally. The resource then gets triggered for a GC. But what the cleanup step does is it jumps one last time into that resources frame, calls beam.yield, raises an error in the Zig system. That triggers the defer. And so that's how all of that stuff got cleaned up. OK. Does that make sense? It's not the simplest thing to understand, I guess. But the other thing that is, I think, important is that, let me do this. So I said that there were different execution modes. So I can run the same program. And so note this loop threaded simply calls the loop yielding function, right? And instead, if I can do the exact same thing and run it in threading mode, and it will have the exact same behaviors, even though the beam.yield function is configured in such a way that it can run successfully whether or not it's in yielding or threaded mode. So let's go ahead and do that. So we are now consuming 30 megs of memory, and then we're going to do OK, so 41 megs, right? So that's a little bit more than 10 megs. And then if I process.exit v2 with the instruction kill, and then we do memory, 31 megs. So this is running in threaded mode, which means that it's running inside of an operating system thread, instead of using this crazy tail call, blah blah blah. But note that it's calling this loop yielding, which is actually an asynchronous function. So Zig has something called colorless async functions, which means that you can run an asynchronous function in synchronous mode, and you don't have to make any changes to your code, and you don't have to do weird things like write your own event loop. Last thing is, this is one of the reasons why NIFs are dangerous. So I'm going to run this loop sync. And what has happened? I've like I'm typing and you can't, nothing's going on. This is why NIFs are dangerous. So here we are just doing something synchronous, and basically it's just hogging so much of the CPU time that nothing can happen, nothing more can happen. And so we don't have any memory leaks, or we do have a memory leak, but we don't have any we don't have any seg faults, and we don't have any panics, and yet we did something really dangerous with NIFs. So do be careful. But I do think that I've tried to put in enough conveniences that it's easy to write good programs, and you can easily test between yielding and threaded and do an A/B test. Do I need to do threaded? That's a really heavy-handed process. I'm creating a new operating system process or operating system thread. Maybe yielding's better. Okay. So I think I have time to do another quick demo. So I would like to show you Alex Kutmas's ray tracer. So a couple of weeks ago, Alex built this. And so this is, you can't do a talk without some sort of live view demo. And what this is this is a live view that has in its live view running Zig code through Zigler. And this is kind of, it might look like it's just moving this bitmap left and forth, so you kind of have to trust me and or look at the code. But it is doing a ray tracing of this scene under the hood every time via Phoenix Live View. And so I was really flattered that somebody's like, hey, this is useful, and let's try something crazy with it. So there you go. You can play with this. I think he's Kutmos on Twitter, Koutmos, and see for yourself. Okay. All right. This is just a browser. All right. So what's in the future? So core Zigler is almost done. I'm expecting maybe 1 or 2 more breaking API changes. I want to redo some of the way that I translate between the statically typed Zig stuff back into Beam with even more easy interface. I'm going to start working on supporting multiple Zig versions, which will be more important as Zig kind of becomes a 1.0 project. Want to integrate the Zig package manager. That is supposed to be a pre-1.0 development. Currently doesn't exist. And I have a personal commitment to support Zigler through Zig 1.1. But I would love to have some help maintaining this once Zig becomes a real thing. Well, I mean, it's not a real thing now, but Okay, so in conclusion, Zig solves these 3 problems. It should be possible to write NIFs with the same level of joy as writing Elixir code. I've got a high level of integration with Elixir and writing NIFs that work really well with the virtual machine. So here's my call to help. I do everything on Linux, so it's really hard for me to get. I think macOS works, but there might be some issues. I don't know. Windows is definitely something that needs some help. I think I might have solved it. So that nice inner code highlighting that I have this VS Code Zigler extension. I just need some help. Somebody just needs to put that on Azure because they don't have an Azure account. And it's literally ready to go. So that's the easiest one if you want to help directly with the project. And there's one more thing I don't understand how. So if you notice that if I make a code change, I have to exit out of the VM and then go back in. There is some way for you to do module reloads, and I'm not quite doing it right. So if somebody is an expert on that or knows somebody who's an expert at that, at me on Twitter. And I have a call for apps. So one thing that I kind of started the framework for, but wasn't really able to put any time into, is a project I call Exla, which is a CPU-only backend for NX that calls Zigler. So if somebody would love to work on that and knows how to do that stuff, that would be awesome. But it's gotten started. It's on my GitHub /exla. And then a porcelain replacement would be cool because I don't like having to download the Go binary. It would be nice for it to be built into the library, I think. I mean, that's just me. OK, special thanks, Jose, for building such a crazy, awesome language that this is even possible in. Andy Kelly for building Zig, which, it's not like, it's crazy easy, but it was not, there were no parts of doing this where where I felt like I was stymied by what was possible. And Alex for building the live view little demo. If you're interested in Zig, I recommend this video called The Road to Zig 1.0, which is really what sold it on me. Ziglang has its own website, and there's a great place to learn Zig called Ziglearn. And the library that I talked about is Zigler. NIFs talk. I gave a talk about NIFs, and there's a really crazy demo there. Supposedly there's a good chance that'll wind up being on YouTube, so keep your eye out for that. And thank you guys all for coming to listen to me. Yes.
For those of us who are new to NIFs and performance hunting, like low level, what like high level guidance would you give us if we're, trying to make something faster? Should we reach for NIFs, or like what are some guiding principles that you go by?
Well, I've actually never deployed anything with NIFs. I should have mentioned that. None of this is in production, so I can't. Sorry. Ask AppSignal. How about that? Yes. Right, so it's a little bit of a lie. That is an error return trace that I have turned into a stack trace. Okay. So yes, great question. You caught me out on fudging the truth a little bit. Yes?
So you talked about making integration style tests between Elixir and Zig. Would you advise doing property tests to really like lock that down, since NIFs are scary? What are your thoughts?
Yeah, probably. That's a good idea. Yeah.
So there was a slide where you were kind of explaining what was happening. You mentioned about the garbage collection. Was that in the Beam or the Zig automatic garbage collection? I didn't quite get that.
That is the Beam garbage collection event. So the process death triggers garbage collection. That red line was the resource. So that resource, and then you can put a hook into a CABI hook into the resource that gets triggered when that resource gets destroyed. So I'm basically tying the NIF into a garbage collection tracked item in the VM. Yes?
So one of the really good things I saw was that you were kind of inferring type specs from the NIFs, that's pretty sick.
Yeah.
What if I'm returning, you were doing it with numeric types, which is probably relatively straightforward. If I'm in Zig and I'm going to return some kind of like some composite record from Zig, is it going to show up back in Elixir land as a type spec of like a binary, or how do you infer that for those sorts of things?
Right, so I only allow something like 20 different types to go back and forth. But so I mentioned that I want to overhaul how types are converted, or how some of the statically typed things are converted, and that is like, I think that there might be a way to get tuples in from Zig into Erlang land. And I think there might be a way to get structs in for Elixir folk. Yeah.
And kind of as a follow-on to that, I'm guessing that a lot of our, we kind of take immutability for granted, and once you reach out to Zig to do stuff, you can totally get back what might have changed.
Treat it as like a database transaction. Like that's mutable. Or process library. Yeah.
When you load the external libraries, is that Erlang loading that, or is Zig somehow statically linking? Like you were linking with the what is the thing that the math library?
Oh, actually, you know what? That's a great question. I don't fully know exactly what Zig is doing. I think Zig is doing a static linking into the dot. So the Zig emits a .so file, or dilib, or DLL, depending on which operating system you're in. And I think what Zig is doing is it's statically linking that BLAS in. You could have passed the .a file and the .a BLAS static library, and it would work just the same. Because I think that I've deployed this on a system which taken, just as an experiment, taken that artifact that like made a release, and then released it to something that didn't have libloss, and it worked.
Yeah, so if that shared library does
I think it doesn't. It does not. Yeah.
What are compilation times like? Is it painful, better, worse?
You know, you saw what the compilation time was. I mean, I don't know how else to say about that. I mean, like, you know, it's not so much that, so the test suite for Zigler is like all just sigil Z's up and down a bunch of, I guess, integration tests. And it's like maybe 20 seconds on this not so great laptop. So Zig's are pretty good at compiling fast. And it's getting better because that's something that the team really cares about. And they're also going to start, I think maybe in the next version, they'll start having like incremental compilation solutions. So that'll kick the compilation time even faster. And then Zigler has a way for you to say, do this in release mode. So you know, you don't have incremental compilation and release. You have a nicely polished binary that comes out the end that's like doesn't have all this like scar tissue from previous compilations. So yeah.
Is there a way of including Zig stuff not using the Zig sigil? Can you like just reference a file and say, go jump this?
The entry point has to be sigil Z, but if you wanted to, you could do an @include path to some other Zig file that you keep in your tree. So like, you know, you can reference other, and the system will hunt down where those are using the parser and say, oh, it looks like you're trying to include this other Zig file. It'll drop that into the temporary directory where it does all of its, you know, scheming. And then, and so it'll make its way in there. And of course, package manager stuff, not yet, but like soon. Yes?
Don't get me wrong, this is really cool, but like, why did you do this?
Oh, the ping, the ICMP ping. The ICMP ping thing. I don't know if you were here for that. Oh, yeah. So originally, I wanted to have ICMP ping for the Beam virtual machine. And so that's how, like, this is a 2-year yak shaving project. Anything else? I think we're just about out of time, too. So thank you very much for coming.